Welcome to a video presentation of Chapter 5, Section 5 in McDougal Littell's 8th grade textbook entitled Fractions and Decimals. We start with all those definitions that we have on the left side of the board, starting with natural numbers. The natural numbers are what we also call the counting numbers. So of course that starts at 1. It will be 1, 2, 3, 4, 5, keep going up to infinity. Also called the counting numbers. Whole numbers. The natural numbers including 0. Whole numbers. The natural numbers including 0. So that's the list I just read off, but you start with 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Go up towards infinity. Integers, you know what integers are by now. Integers, two different definitions I give you, 2 for the price of 1. Numbers that appear on a number line, or the natural numbers, their opposites in 0. Numbers that appear on a number line, or the natural numbers, their opposites in 0. So that's your 1, 2, 3, 4, 5, 6, 7. All their opposites and then 0. And it has to be said that way. All right? Because if you say the natural numbers 0 and their opposites, there is no opposite of 0. There's no positive 0 and negative 0. There's just 0. Okay. So it does have to be said in that way. You have to say the natural numbers, their opposites, and then 0. You can just say numbers that appear on a number line. You don't have to deal with it at all. Rational numbers. Almost every type of number is going to be a rational number. That's any number that can be written as a fraction. Any number that can be written as a fraction. And then we have irrational numbers. Irrational is different from that whole set. Irrational numbers are anything that I cannot write as a fraction. There are very few things I cannot write as a fraction. Pi would be one of them. A lot of times we say pi is 22/7, but remember, it's not really. That's just a close approximation. Pi is something I can't write as a fraction. Square roots that aren't perfect are usually things that I can't write as a fraction. Pretty much all of them. Okay. Very few irrational numbers. All of these are called real numbers. As you can see up here on the TV set, I've got this diagrammed out for you. Got this diagrammed out for you. As you can see, the small box here in the middle says natural, because natural is the smallest set of numbers we have. That's only everything from 1 up to infinity. You can see the next box is whole. Whole would be all those same numbers, but you throw 0 on, so it's a little bit bigger. Integer, again, a little bit bigger because you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're opposites, so all the negatives, then you throw 0 in. Rational, that's anything I can write as a fraction. There's a whole bunch of things I can write as a fraction. And you can see those are all in the box called real, because they're all what we call real numbers. Now you're asking me, well, is there something else? Yeah, there is actually. There's what we call imaginary numbers. Imaginary numbers are when we take the square root of a negative number. The most common imaginary number is the number I. Yes, I said that right. I can be a number in mathematics. Go figure. Okay. That's a whole different thing that we don't have to deal with that. And you can see irrational is out here on its own because it doesn't fit in with these. Right? Irrational I can't write as a fraction. Now, you can say, well, why are these boxed like that? They also encapsulate everything they are. Think about it. If I'm talking about a whole number, I'm talking about 0, 1, 2, 3, 7, 8, 9, 10, all those. Remember, the natural numbers, those are just the 1, 2, 3, 6, 7, 8, 9, 10 part. Well, that means that natural numbers are also whole numbers. Okay? So if you're saying something's an integer, then you're telling me it's also whole and also natural. If you're telling me it's a real number, all right, then it's one of these or this, right? Or all of these and that, or that, depending on what you're talking about. Okay? So it's an encapsulating thing. They could be more than one type of thing, depending on what category it fits into. And I'll leave that up there for a while. I'll put it back up afterward. So if you need more time to write it, you can. All right, so we got 3 things we got to do today. We have to convert fractions into decimals. We have to write terminating decimals as fractions. Those are 2 things we've done. And we have to write repeating decimals as fractions. That's something new. That's the one thing you haven't done. All right, so let's start with example 1. We're asked to turn 5/11ths into a decimal. You've done this before. You don't like it. When we're turning a fraction into a decimal, that's when we do long division. You've got to divide the numerator by the denominator.